Probability review number 2. Welcome back. When we last left our heroes, they did probability review number 1. We reviewed some basic concepts of dice and coins and spinners and food that's disgusting to think about in a middle school cafeteria, like sushi. Now we're going to get into some more complicated questions that deal with statistics and probability, and there are some really kind of fun situations. So let's dive in and let's take another jump into the world of probability. Oh, wow! Let's start a new one. I did this recently, so let's start fresh though. Number 1. All right, a person chooses between 4 hats and 2 pairs of shoes. There are blank possible outcomes. The last couple problems we did on probability review number 1 featured a die and a coin, and we multiplied them together to figure out the total number of outcomes using something called the multiplication principle of counting. So if you're out there watching in the world, hello, you can actually do this right now. You can go into your closet and you could look at all the different number of items you have. So how many different, I'm just going to call these tops. Let's be really general. So all your t-shirts, your long sleeve shirts, your dress shirts, everything. And then you could say, all right, how many different pair of shorts do you have? How many different pair of pants do you have? Then you could look at socks and shoes. You would get super fancy, look at hats. If you have different watches or other bracelets that you wear. Whatever these numbers are. So say I don't know, I'm just going to write some numbers here. All right, whatever numbers you get, if you want to know what total number of outfits you have in your closet, you simply just multiply all these numbers together. So hypothetically for me, not counting shoes, not counting hats, any of these other types, just with the tops, the shorts, the pants, and the socks, I would have what looks to be 10 times 200. I would have 3,000? Is that right? 3,000 outfits? I think that's right. Holy cow. So that means I could wear a different outfit every day, and I'd have about 10 years worth, not including shoes. It's just amazing. And yet, so often we don't wear different kinds of outfits when we have our clothes in the morning because, maybe they don't match. That has never stopped me, though, I'll tell you that, especially some collegiate outfits that I just wore what I wanted to wear. Props to anyone out there who just wears what they want to wear. Who cares if it quote-unquote matches? It's about what you want to wear. All right. Using that multiplication principle of counting, let's look at number 1. Person chooses between 4 hats and 2 pairs of shoes. There are blank possible outcomes. That so simply is just your 2 numbers times each other. 4 times 2 for me is 8. Okay. Nice. All right. Number 2, we immediately get into problems that people often miss. So pause the assignment if you're out there and you want to try this on your own, and then I will show you how to do it if you miss it or if you just want to check it. All right, welcome back. A person tosses 4 coins. There are blank possible outcomes. Now, you might have a different number of coins here. You might have 5 coins, 2 coins, 3 coins. Probably not more than 5. Maybe you'd have 6. But anyway, some amount of coins. Let's think about this. If I have coins, these are perfect coins. Actually, I can be really fancy with this. I'm going to flex for a minute here because I have the ability to draw like circles that are all kind of perfect. So like that. Ooh, look at that coin. That's not a coin. Let's copy this though. All right. So I'm going to end up with 4 coins and they're all going to be identical. All right, 4 coins just chilling where they're chilling. Each one of these coins has heads or tails as an option. So they each have 2 different options for what they can land on. I know from the multiplication principle of counting that you can use on the clothes in your closet that we simply just multiply these numbers together. Now people look at this and they they undo it correctly. They unholy create the calculation. They just do it wrong because they look at this and they go, oh, there's 4 coins, 2 times 4. Oh, it's 8, right? Wrong. No. Because 2 times 4 is the same thing as 2 plus 2 plus 2 plus 2. And maybe you've never thought about what multiplication actually is, but that's what it is. It's skipping steps of addition. We don't want to skip steps of addition. We want to do multiplication. So 2 times 2 times 2 times 2 is actually 2 to the 4th power. Oh, so you could, I'm going to close this in 3. Sorry, coins, you're so beautiful. 2, 1, boom. Is that change you can believe in? Coin jokes. Okay. However many coins you have will be your exponent. And you're going to type in your exponent down here with this A to the B button. So if you have 5 coins, you do 2 to the 5th. If you have 4 coins, you do 2 to the 4th. You could also just type it in 2 times 2 times 2 times 2. You're going to get the same answer each way. Just make sure you type in the correct number of coins based on your problem, not my problem. Why did I not type in 16? I think it's one of those situations where I was just talking as I was typing. It's like texting and walking. I literally it said 16. Okay, well, let's do another review problem. So if I have 2 coins, this is kind of simple because this is one that tricks people, actually. It's a good thing we're doing this because, wow, and I just typed 4. Am I a prophet? 2 times 2 is the same as 2 plus 2. So if you get 2 coins, some people move on never knowing that they did the problem wrong, technically, if they did 2 times 2. Because that strategy would not work for any other situation. They just got lucky. All right, 3. A soccer team's kit. It's a fancy English word for the outfits that soccer teams wear, a football. Consists of 3 jerseys, 2 pairs of shorts, and 3 pairs of socks. How many soccer outfit combinations are possible if each outfit contains 1 jersey, 1 pair of shorts, and 1 pair of socks? This is like the clothing in your closet hypothetical situation. We just have 3 jerseys, 2 pairs of shorts, and 3 pairs of socks. So whatever numbers you have, just multiply together. So I've got 3 jerseys, 2 pairs of shorts, and 3 pairs of socks. So for me, that's 18. Multiply your numbers together, not mine. And look, I actually typed in 18 instead of 4 for some reason. Number 4. We'll profit again. Heather finally narrowed her clothing choices for the big party. Wow, Heather, you're doing a big party right now. Maybe it's a virtual party. To 4 skirts, 4 tops, and 3 pairs of shoes. Talk about flexing. Jeez, Heather, just choose something already. How many different outfits are possible from these choices? Same exact thing we just did. Now we have different numbers. Heather. Wow. If it's a virtual party, people aren't even maybe going to see anything below your waist. So don't worry too much about the skirt choices. 4 times 4 times 3 is 48. I did type that incorrectly. And we'll never know what Heather chose because it's a made-up problem. Sad. If your name's Heather out there, hello. Hopefully you have a great party. All right, number 5. The ice cream shop offers 23 flavors. LeBron James. You order a double scoop cone. How many different ways can the clerk put ice cream on the cone if you want 2 different flavors? Well, this is another one that always seems to trick people. So you walk in an ice cream store. Oh, that'd be lovely. If you're like me, you're going to order the most chocolatey, peanut buttery thing they have. Or if they combine like cookie dough and peanut butter brownies. And oh my gosh, I'm going to make myself so hungry. Yeah, well, anyway, where was I? Sorry, I blacked out there for a minute. We have a certain amount of flavors in our ice cream shop to choose from. Now we order a double scoop cone. Let's make that brown. So I'm going to get my hand-dipped waffle cone. Waffle cone. And I am going to choose that chocolate peanut butter creation for my first scoop. Looks so good. 2-dimensional little black circle there. How many different ways can the clerk put ice cream on the cone if you want 2 different flavors? So I got 23 choices for my first flavor. But I have to choose a separate flavor. Like say, let's just go simple. I know they'll have it. Chocolate chip cookie dough. CCCD. Chocolate chip cookie dough. Good. Half chocolate chip cookie dough, half chocolate peanut butter. Or Ben & Jerry's has this half-baked flavor that's chocolate. It's chocolate chip cookie dough and fudge brownie mixed together. So, it's not a half-baked idea. Who came up with that one? Anyway, I cannot choose chocolate peanut butter for my second flavor, but I can choose all the other ones, even the ones I'll never order, like fruit flavored stuff and I don't know, lavender, all these weird flavors that Salt and Straw has in Portland. So I can choose anything but chocolate peanut butter, meaning I can do 23 minus 1 or 22 different options. I just can't repeat the first one. So whatever you got for your first flavor, do that minus 1 for your second flavor. Multiply them together. I'm going to do that in 3, 2, 1. Bye-bye, ice cream. 23 times 22. I get 506. So whatever you get times itself minus 1. And the next one features some southern spelling. There are 13 bands participating in a competition. And how many ways can first, second, and third place be awarded? Write your answer without commas. This is kind of like the situation we just had, but instead of a double scoop, we have a triple scoop. We have 13 different options for first place. Then somebody wins first. Yay! I won first. And I don't have any hair or worries in the world. So that same band, I guess this band of 1, maybe I'll give them one other person. Band of 2, and this person just gets 1 off-center eye. They win first place, so they're out. That leaves 12 different bands competing for second. Somebody wins that. Yay! That leaves 11 for third. So just like you did whatever number you had for me, 23 times 22. Now you're going to do whatever number you have for the band times itself minus 1 times itself minus 2, and then you're just going to stop because we only have 3 places. So for me, that's 13 times 12 times 11. There are 1,716 possibilities. That's a lot of possibilities. Okay. Number 7. How many ways can 5 different people stand in line? I don't like that one. I want to do the big one. I want to do 10. So I'll do 5 as well. But some of you guys out there have 10 people. Some of you have 8. You have a number probably up to 10. I don't think it's larger than 10. But I love the 10 one because it's such a fun problem to talk about. So we're at the movies. We're going to go see a movie that we all want to see, or that, probably statistically only half of us want to see, and maybe the other half are just hanging out, or they're bored, or they're trying to get a date or something. Just put up with some movie they don't want to go see. 10 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. We have 10 different people standing in line at the movies. So you and 9 friends. Now, I just want you to think about that for a second. You and 9 friends standing in line. You're in some order. Single file line. You got to stand in line to get tickets. Now, all of a sudden, someone's like, oh, crap, I got to go to the bathroom. So they go to the bathroom. See, get it? Crap, bathroom. Bathroom jokes. And they come back, and they are all of a sudden in the back of the line. There's a different combination. And then somebody else is like, ooh, I need to go charge my phone. And they go back to the car, and they charge their phone. Maybe they get their car charged or whatever. They come back. Now there's a different order. The question is, how many different orders can those 10 different people have in line? So take a moment and just guess. I can't hear you, obviously, but just shout it out or just say it or think it. Often people say, I don't know, 10 people, 10 choices. Or maybe they know it's more than 10, so they say, I don't know, 100. Or you get crazy and say like 1,000 choices for those 10 people. Think about 1,000 different possibilities of standing in line. That would take forever to just stand in line all those ways. You'd miss your movie. Well, here we go. We got 10 different options for that first space. But then someone's in line. That only leaves 9 spaces. And then 8. And then 7. And then 6. Oh my gosh. This is a lot of numbers to write out. Whew. Whew. All the way down to 1. That last person who went to the bathroom last. They're last in line. They're the only option. This is a lot to type in. 10 times 9 times 8 times 7 times 6. So hold on. Don't type this in. Trust me. Just watch for a second. You're going to learn something here. Or relearn if you already know it. Whew. Look at this number getting larger and larger the whole time. Did you say, in your guess of 10 different people standing in line at the movies, 3,628,800? If so, wow, you deserve a prize. That is a crazy specific guess. That's a lot to type in. There is a special button in mathematics for this exact purpose. It is what's known as factorial. It does not count for our other two problems because you have to have a certain number, in this case 10, and you have to multiply it minusing 1 each time, but it has to go all the way down to 1. So the ice cream problem was just 23 times 22, and then we stopped. The band problem was just 13 times 12 times 11, and then we stopped. It didn't go down to 1, so we couldn't use it. But because we started with a number of 10, then 9, then 8, then 7, we went all the way down to 1, we can use this. The English language, or just language in general, is going to be a little pissed because they stole their exclamation mark. But it is an exclamation mark. And look, it's the same answer. This is like saying 10. Again, English is just like screaming 10. The same thing for 5. So whatever number you have, just type that number in with an exclamation mark. That's going to be the same as 5 times 4 times 3 times 2 times 1. And I proved that to you with the 10 explanation. And look what it says. Oh, I love puns. That answer is a Blockbuster, RIP to Blockbuster, but not to movies in general that still use that phrase. Oh, Blockbuster, why didn't you buy Netflix when you had a chance? Why didn't you? One of the worst decisions ever. All right, number 8, the last one. Tim, if your name's Tim out there. Hey, Tim has cards with the letters E, T, B, I on them. Now, you might have just T-I-B. You might have an S as well. It's either going to try and spell bite, like mine, or you could try and spell bit, or you could try and spell bites. And you basically have cards with each of these letters on it, and you want to know the probability that you draw the cards in order to spell the word perfectly without putting the cards back. Well, let's follow along. So the odds of me, the probability, we always know it's going to be a fraction, of drawing this B first to try and spell bite. Well, there's only one B out of 4. But then I keep that card. I don't put it back. And now I just have the I, the T, and the E left. Well, the odds of drawing the I perfectly are 1 out of, well, I've kept the B. There's only 3 cards left. And then I have, only 2 cards left. And then I just have 1 card left. This is a factorial of fractions, a fractiontorial. However, let's think about the top. 1 times 1 times 1 times 1 is just 1. And on bottom, I've got my 4 times 3 times 2 times 1, or just 4. Now we're golfing. 4 factorial. So for you, you can just type that in over here. 1 over, if you have 4 letters like me, write 4. If you have 3 letters, you write 3, 2, 2. Oh my gosh. You should be able to. However, this doesn't do it as a fraction. So let's audible here. Let's separately do 4 factorial in its own. Do 1 out of 24. And that's our answer. Okay. So write your 4, or however many letters you have. If you have 5 letters, write 5 factorial. If you have 3 letters, you write 3 factorial. And then just put a 1 on top with a fraction to whatever number you get. So 3 letters would be, let's figure that out. So if you have bit, I'll just end this by giving you a little free answer. That's 6, 1 out of 6. If you have bytes, that's 1 out of 120. You should know that because we had 5 up here, and that matched the 120 to 120. 5 factorial to 5 factorial. Oh, and you rock. I don't know what that has to do with biting. Hopefully you're not going to a concert where people are biting each other, but I don't know what people are into nowadays. All right, there it is. That was a fun lesson. Thanks for playing along, following along. Over 18 minutes, over 19 minutes by the time I'm done with this. Wow. This has been an honor and a pleasure, as always, to be your virtual teacher away from class. This has been Dylan's class. As always, I hope this video finds you safe, happy, healthy, and well. Best wishes with your day, your week, your month, the entire rest of your life. Only the best from your teacher, Dylan.